Hello, everyone, and welcome to Build for Integrity and Reliability within the Software Supply Chain. Today's webinar is sponsored by Docker and produced by Actual Tech Media. Hey, first of all, I want to say Happy Halloween to everyone. Great to have you here. Would love to see in the questions tab what you're going as tonight. What are you dressing up as for trick or treat tonight for those of you in the US? Let us know in the questions tab. My name is Keith Ward. I'm a moderator with Actual Tech Media, and I'm really excited to be here for this special event with Docker today. But before we bring on our guests, I need to cover my regular housekeeping stuff with you. All right, leading off today, we want you to ask lots of questions during the event, which you can do in the questions box in your webinar control panel. Now, we're also going to have a Q&A session at the end of the presentation to go over your questions. So just keep those coming throughout today. Now, that Q&A panel is also the place to let us know about any technical issues you might be having. First thing you want to do if you can't hear or see something is do a browser refresh. That should fix most problems that you come across. If that doesn't work, well, try another browser refresh. If that doesn't work, then hit us up and we will try to troubleshoot as best we can. Okay, second, right next to that questions tab, you'll see the handouts tab. And that is the place you're going to want to go right now because there are a ton of resources, including 6 great downloads from Docker today. Those resources from Docker are everything from best practices for securing your software supply chain to a Docker Scout cheat sheet to links to all kinds of goodness. So make sure you go there and get some of those free goodies. Those are some treats for today. All right, no tricks there, I promise. Other links take you to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's vast library of tech ebooks. There's also a link to the Actual Tech Media Events Center, which has our calendar of upcoming events. All right, next up, at the end of this webinar, we will be awarding a $250 Amazon gift card to one of you. Now, you do have to be in attendance during the entirety of the event to be eligible to win that prize. The official terms and conditions of the prize drawing can be found in the handout section. And finally, one of the best benefits of this and every Actual Tech Media event is the opportunity to pick the brains of these experts that we have on, like the 2 that I'm about to introduce today. So to help encourage those questions, we have a special additional prize, and that is another $50 Amazon gift card. So after the event's over, we're going to look at all the questions that came in. We're going to pick out the very best one, and we're going to contact that prize winner. All right, with that, let's get to the main event here today. I'm really excited to introduce you to our presenters today. They are James Carnegie, Principal Software Engineer with Docker, and Alan Chen, Staff Software Engineer, Replica Analytics. And with that, James and Alan, I think you guys are ready to go. Can you hear me?
Loud and clear, Keith.
All right. Outstanding. It's great to have you both here. Looking forward to what you're going to present to us. James, you're ready to go. So I'm going to turn this over to you now. You have the floor.
Thanks, Keith. Thanks, everyone. Thanks for coming and happy Halloween. As Keith mentioned, I'm James. I'm a software engineer at Docker. And I've been working on Docker Scout since I joined Docker for about 1.5 years. But also before that, at a company called Atomist that you may have heard of, that Docker acquired. So we'll try and keep this short. So I'm just going to cover what Scout is. I'll do a demo that'll touch on some of the things that Scout does, the bits that I'm super excited about at the moment in particular, and then a bit of a highlight of what's coming. And then I'll hand you over to Alan from Replica Analytics. So to kick things off, I wanted to set some context for the space that Scout is operating in. CISA, that means cyber security and infrastructure security agencies, quite a mouthful, but they've identified two main threat models in open source software. That's most of the software that ends up in our runtimes. One is is vulnerabilities that are being discovered the whole time, and the other one is supply chain attacks. We'll mostly be focusing on one, although Scout does cover and Docker does cover a lot more around the second bit, around the supply chain attacks, and we will touch on it a little bit. But these things are coming everybody's way. There's more and more legislation coming out all the time, and certainly if you work in government, you'll be worried about these sorts of things. So what does this all mean to us? As developers, we're always pulling in other people's dependencies, and it's very, very hard to know whether or not we should trust them. We don't know where they come from. We don't know who built them. Are they signed? Do they have vulnerabilities? Are they even up to date? So how do we make sense of all of this? SALSA is a supply chain framework that came out of Google that's tried to address some of these issues. But really it's primarily focused on making sure that the build process itself is secure. And you can't do much more about your dependencies that you bring down from the internet, but you can secure your own build, and you should do that. But before you should really worry about SALSA and sorting out your build, you probably need to figure out what it is you're actually running and where. And that's where SBOMs come in. You've probably heard of it. It stands for Software Bill of Materials. And ideally, they would be built at the time that the software is built and be derived from the build file. But often they need to be scanned. And traditionally, this is done in production. It's a little bit late, but you have all these vulnerability scanners that run in production services, and then maybe you get late feedback from production that there's some vulnerability there, but they miss things and it's not the right time. Really, the software bill of materials should be an attestation that's attached to your artifacts, to your Docker images during the build. And with Scout, if you don't have one, we'll generate one for you, index it on the Scout platform, and then we're able to analyze it. But also, as Docker, we have the tools to produce high-quality SBOMs at the time of build. And do get in touch if you want to talk about that more. I can point you in the right direction. So how does Scout fit into this landscape? Well, the Scout cloud can be seen as a system of record. All of your attestations, your SBOMs, which images are running where, all flow into Scout, and they're stored in an immutable database. And the trusted content that comes from Docker official images is always kept up to date, as vulnerability free as possible. We produce slim images, and that all fits into the supply chain landscape. You need to know what you're running, and you need to trust the content that you're building on top of. And then when it comes to your own software, this is where Scout really shines. It helps you through policy to iteratively improve your software and move yourself closer towards SALSA compliance, but also being free from vulnerabilities. So I mentioned the word policy on the previous slide. Policy at Docker is different to, I think, what other people refer to as policy. It sounds like a legal thing or a blocking thing or a nasty thing, the thing that's going to stop you doing your job, the thing that's going to slow you down, the thing that's going to fail in production, and all of those negative sorts of things around enforcement and so on. But at Docker, we don't really see it like that. We see policy as being an enabler. So with our policy, the rolling it out, for example, is an iterative process, not where it's in warn mode and then you turn it on, but it's all about comparing one image to the next image, or your current image to the one in production, and looking at the differences. So did you make it better or did you make it worse? And in the demo, you'll see all sorts of ways that Scout makes it easy to set policies. They're kind of more like quality targets for your software, and not only security. It might be number of bugs or code coverage or whatever it is. But Docker Scout policy is a developer tool to help move your organization towards better software, and if you're that way inclined, more compliant software if you work in that space. And also our policy is kind of different in that it doesn't just say yes or no, it outputs the remediation. So when a policy fails, it tells you what was wrong and what to do about it. Of course, you can use it in the conventional way and plug it into CI or production admission controllers to block things. But we're finding that kind of approach doesn't get you that far until you've got a good baseline, and Scout will help you get there. So with that, I'm going to try and do a demo. So I've just prayed to the demo gods. So this should work just fine. Hopefully you can all see my screen. This is scout.docker.com. And the story I'm going to tell you is one where a security engineer in my organization has told me that one of my production images has got a new critical vulnerability. And so I go to scout.docker.com and I need to figure out what's going on and try and fix it. So here on the overview screen, I can see an overview of all of the images in my organization. Now, there aren't many. I've only got 5. This is my test setup. You probably have more. And I can certainly see that there's some vulnerability trends going on here, and I want to get some more detail. But I was also told that this was in production. So I'm going to go and check out the production environment. And I can certainly see that there are no images that comply to this particular policy, which is one that says there should be no critical vulnerabilities. And then I see also another one here that we shouldn't have any critical or high vulnerabilities that have fixes. So that makes no sense at all. If you can fix it, then why shouldn't you fix it? That's a kind of a no-brainer. So I'm going to have a look at that. And here we go. So this is my image I built 5 hours ago. A new vulnerability has come in, it seems. So I want to get to the detail and try and fix this. And Scout's going to help me. So we can see this is the zlib vulnerability. I don't know if you've heard about it. It's quite old now. I shouldn't really have it in my image. I do want to find out how it got in there. So I'm going to dig a little bit deeper there and find out which layer it's on. So here is a breakdown of the layers that have gone into my image. Those of you who use Docker files will understand that most of your statements in a Docker file make another layer in the file system. And here we can see actually that zlib has a fix, and it was introduced actually in my from line, which means it's in my base image. Anyway, as an engineer, I'm more interested in command lines rather than GUIs. So I'm going to try and check it out over here. And there's a whole bunch of Scout commands. If you install Docker Desktop, you'll get Docker Scout and command line. And here I'm just using the quick view command. And I'm going to examine what's going on with that image that I've just been told about. And I know it's this particular image. And so here again, we can see the critical vulnerability. We can see which base image I've used, and you can see that it's which policies it's violating that my organization has set up. But I want to know more than that. So I'm going to look at the Scout CVEs view. Now, there's a lot of information here, but a lot of it's very pertinent. So I'm going to scroll to the top. And here's the zlib package that's vulnerable to this nasty CVE. There's a fix here, and I can see that it's on line 5 of my Docker file. So I happen to know how to fix that. I'm going to create a new branch. And I'm going to fix the Docker file. And I'm cheating here a little bit. and then I'm going to build it. And here I'm using Docker's build, which should add some provenance for me as well. So SBOMs and so on to my image. And now is the really cool bit. I can compare the image I just built with the image in production. You see there 2env prod. That corresponds to the production environment that I've got set up. So I've got an agent, maybe it's Sysdig, reporting which images are in which environments into Scout. And I know that the main version with a vulnerability is running in prod. So I'll compare this. So that what that's doing is it's extracting the SBOM from my local image and evaluating the policies against it and evaluated locally, and then pulling down the policy results from scout.docker.com and comparing them. Now there's a huge amount of information here, so I won't go into every single bit of it here. You should check it out yourself. But you can see here that the image I compare against is the one that's on scout.docker.com. And we can see actually this is where it came from source control. This is the provenance attestation that I spoke about. And we can see also that we've now fixed that vulnerability locally. In fact, we fixed more than that. We fixed the critical is gone, but actually all of them are gone. So we ended up with a 0 vulnerability image, which is great. It also shows a whole bunch of other diffs. So for example, I haven't actually put these labels on here because it wasn't a CI build. So I haven't put all of the good hygiene things into my Docker build yet. And here's the policy results. So we can see here, we also fixed, I know we didn't change that. So we've got some GPL packages, which some people might consider toxic. They haven't been removed. But I have fixed the vulnerability and the critical high vulnerability with fixes policy. So there's more in here. We've added packages. We've removed packages. All of the versions are here. We won't go into the details. There's too much there. But what I will do is push this. Let's fix the vulnerability. Sign it, of course. And let's push this. So I push that into GitHub. And here we are over in GitHub. We will create this PR. Now here comes a clever bit. We've configured GitHub Actions with the Scout GitHub action down here. Actually, it's my fork of it, but that's okay. You can do this as well. And the important thing here is if the PR in any way makes the image worse, it's going to fail the build. And so it will compare the current policy results with the historical policy results. And even if the config changes, it's smart about that. So for example, if you change your policies, you add a policy, remove a policy, it's not going to just break the build. So this is really developer friendly. It wants you to go to production. But if you made it worse, so you introduce a new critical vulnerability or something that breaks your policy, you can configure this to break your build. So that's pretty cool. So hopefully that PR has made some progress. It hasn't, it's still running. So I'll show you this old one, which I made earlier. And so you can see a similar comparison. This is the production image, and this is the one coming in from the PR, and it's doing the diff here. And this is in much healthier shape. We've got provenance in that they have commits associated with them. And you can see down here in the policy section, again, like on the CLI, where we can see that we've made it better. And we definitely haven't made anything worse. So this build has passed. So we think this approach of using deltas and comparisons between local images and your target environment is a bit of a superpower. And people are definitely very excited about it. So that's the end of the demo. Now I will tell you a little bit about what's coming up with Scout. So standard roadmap disclaimer. This is stuff that we're working on or thinking about working on or people have asked for. So it's currently in the roadmap, but we're not making any promises and so on and so on. So I worked on the policy stuff myself, so I'm particularly excited about that. We're going to make them configurable. At the moment, you can only have Dockers out of the box ones, and obviously that's not going to work in a lot of cases. But you'd be surprised, given the way we approach deltas and ratcheting forward. Actually, people are finding them more useful than you might think. The idea of custom policies, maybe you have your own data that you want to integrate into Scout and you want to build your own policies. So that's all coming too. The most exciting feature that's coming up is probably the automated remediation. We're working on that now, and it's probably going to be around keeping your base images up to date automatically, because that's one of the hardest things for people is, first of all, knowing that your base image needs updating, and secondly, actually the mechanics of updating it, which digest you want and why. Is it compliant with policy? Is it going to make things better or worse? Is it going to break the build? All those sorts of things. And Scout is in a great position to help with that. So finally, if you do want to learn more, do go and check out docs.docker.com. There's also a community Slack. I haven't put that up here, but there you can find me and the rest of the team and chat with us about Scout and ask questions. So with that, I'll say thank you and thanks for listening, and I will pass you over to Alan. Over to you, Alan.
Hey, thank you, James, for the excellent talk and demo. Okay, and now let's talk about our replica analytics experience using Docker Scout. Let me go to my next slide. So here is a brief outline that the things were covered in my talk. I'll give you a quick overview about what replica analytics does, and then talk about our Docker image pipelines. Then we talk about the challenges in our Docker image pipeline and why we pick the Docker Scout as a solution to scan the image and for our pipeline support. A little bit of my self-introduction. So I'm a staff software engineer in Replica Analytics, and I have using Docker since 2012 with intensive experience using the Docker. So Replica Analytics is a small startup that's founded in 2019 in Ottawa, and we have 25 dedicated employees. We mainly focus on the synthetic health data generation and the risk management. So we acquired by a New York-based startup called ATN in late 2021. And as you can see on the right side is our technical stack, and it's a very general overview. So as you can see, we support multiple cloud vendors, and because of that, so Docker played a key role for our deployment. Otherwise, we cannot support multiple cloud vendors. So now the next slide, I will talk about our Docker image pipeline. So we have two Docker image pipelines. The first one is a replica microservice, our own Docker images, and the other one is basically the third-party open source Docker image that we use, how we build our things. So let's first talk about our base images. As the last slide, you saw that we mainly using the Python and the Python as a backend microservices and the TypeScript as the front end. So first step is we always need to pick a good base image. So we're using the Debian as a base image, and it's from publicly, and then we do the vulnerability scan. So we always try to pick the latest, but if there's things happened which cannot fix, as you may know, that the latest Debian, which has a one critical vulnerabilities which has no fix yet, possible fix yet. So we will track the issue in our Jira tickets. Otherwise, we will keep trying to update the base image to the latest, and then try this flow again. After we got our base image, we are going to, in the process of our building our Python base image and our Node.js base image. The same logic, we will also do the vulnerability scan, because when we build this Python base and the Node.js base, we will possibly be able to rebuild it, or if issues happen, we cannot at that time, we don't have time to fix the vulnerabilities, or there's no fix for that vulnerabilities. We have to log the Jira ticket to track it again. After that, we began to build all these microservices Docker images, and the same step is the same. And for vulnerability scan again, and the issue, track the issue, and eventually, if we satisfy the vulnerability scan result, we are going to do a deploy. So this is our general microservices Docker image pipeline. The next one is about the open source software. We used quite a few open source software to help us to help our application. So the image will be a little bit small. So the first step is we actually, to get the Docker scan, we actually retag this Docker image from public Docker Hub to tag under our repository, so that we can push it into our private Docker Hub to get a Docker scan. And after that, we began the vulnerability, the first round vulnerability check. So at that time, we possibly got a solution that, hey, maybe we can find a alternative solution for that open source third party. So one we usually go to use is Bitnami's Docker image, which is provide excellent choices for many open source software, and it well maintained by the community. So we are going to using that and try it again and do another round of vulnerability scan. At that time, we'll probably make a decision. So whether we are going to pick the official third party Docker image, or we are going to choose the alternative one, which provided by the community, maybe the Bitnami's version. And if both things still not work, and then we will begin to look at the source code of these open source third-party Docker file, and we are going to build our own version to overcome these vulnerabilities and provide us some way to build the things that we want. And once we begin that loop, we are going to build and test these Docker images, and then through the vulnerability check. And one important part is we need to do the the basic function test to make sure when we build our own images, or we retag the images from the open source repository, the basic function is still working. Otherwise, there's no sense. We just rebuild an image which does not function as we want. So then we are going to, if it failed the function, we are probably going to reinvestigate and try to fix it. If it's get passed, we are going to do the deploy stage. So as you can see, so both pipelines, so vulnerability scan play a very important steps. It gets hit by multiple times, because this is the way that we want to secure our software supply. We are in a shared responsible mode these days, especially for the cloud. So I take a picture from the typical AWS shared responsible mode. So for our software going to deploy it in cloud vendors, so a Docker image will definitely hit the application part, and also we are going to hit the operating system and the network settings part. So it is quite important we make sure when we deliver the software, we're going to fix some high critical and high vulnerabilities before we ship the software. It is important to our clients because our clients is some top 20 pharmacy companies, some large hospitals, and quite a few retail big companies. So they need to follow their regular compliance during their business. So, for example, the HIPAA compliance. So they always require the policy and the rule to check all these vulnerabilities. So it is important we make sure we get the vulnerability fixed so that we can gain their business. But vulnerabilities fix is quite challenge, especially the whole pipeline things. So I actually, I listed the three biggest challenge for us. So the first one is Docker. Be honestly, it's a container, so it's actually a closed box. It's a black box, especially when the first time you begin to using the open source software, these Docker images. I put an example here, which is a mini IO. So the first thing is if you go to the public mini IO, hey, they don't have this vulnerability scan. So of course, because it will cause the actual time and actual event to scan the things, and so you don't have it. So the typical way is you're going to retag it, and then as our pipeline did, we retag it to our own self, and then we somehow can gain the knowledge about the vulnerability list. Another thing is, okay, right now I pick so the right side, I show you two results. It's maybe a little bit hard to read, but in general, there are two different images. One is I retagged from the official mini IO, the latest version, and the other one, the top one is actually for the same version, I took from the Bitnabi's Docker image, and they have completely different results because they built differently, and you have no idea initially which one I should pick, which one actually has the vulnerabilities, which basically there's no fix, and it actually has good quality to ship to the clients. So this is the first challenge. Now the second challenge is, if you're using different tools, you will be surprised to see, hey, they have different results for all these vulnerabilities. They sometimes even give you some false positive results. So I took the two great tools that we used before the Docker got on market. We usually use these tools to scan our Docker images. One is a grip, another is Trivi. Both are great products. But yesterday, before this talk, I just tried to scan this mini IO, exactly the same image as you show the last slides. So for the grippy, if you see, hopefully you can see it. So the last three items that it shows to me, it has three critical vulnerabilities, but in fact, it is one fix, and it confused me. Say, should I report these three critical vulnerabilities to clients or not? Or actually, it doesn't matter. It's maybe not critical anymore because it's so old, it have no solution, and the community already overcomes these critical vulnerabilities, right? Then if you scan the same version using the Trivi, this is the next one, and it told me that there's no high vulnerabilities. There's no critical vulnerabilities. What happened to us? Like, how can I know, especially for the regular software engineer without a lot of security knowledge? what we can do to say, hey, this is our Docker image, and this is the thing that we want to show to you, and we want to ship to you. We need to generate a good report to say, hey, this is our vulnerability list. Then another thing is, it's very hard for us to develop our Docker images because these are different tools showing the different result, right? So typically, our Python developer won't be able to know these Linux packages knowledge, and they don't know how to start it. And another thing that example I want to show here is the RayDoc images. So RayDoc images, you can see it only provide AMD version. They don't have the AIM version. So we have to build ourselves. We actually began to using the docs. If you're using the tool like the previous Travi and the Grip and the Travi, you have no idea how to build a your own Docker using the Docker file because it does not give you any hint idea for these multiple layers. But with the Docker Scout, you begin to we can develop your own Docker images. You can write all these statements by yourself, and then you can go through lay by lay to see, hey, this is software that I want to introduce and install on this lay, and then this one actually I have fixed. For example, so the image here, you can see we have some vulnerabilities, but these vulnerabilities are because we're trying to experiment to run the Spark on the Ray, and we actually install the Spark to support the Ray usage. So these things, the public Docker image for the Ray won't going to provide us. We have to build our own solution. So in summary, as you can see, Docker Scout helped us. We began to using the Docker Scout as our standard solution. And the next step, what we actually going to do is we actually train more junior developers and even data scientists to using the Docker Scout. So help them to understand the basic Docker images, help understand what's the tool they can use, what's the package version they can choose, and how do they fix the Docker file if they actually create a new Docker image for us. Another thing made me so excited is about the policies, especially the one that we really care about is that the license. It is an important area when we ship to the clients to avoid we violate the license rules. So this is my short talk. Thank you very much. And now I think it's time for our Q&A session. And let's bring the cats back. Thank you.
Hey, thank you so much, Alan. Great presentation from both you and James. Boy, did we learn a lot, for sure. Are we ready now for some questions? Then looks like we've got some really good ones coming in. So what I am going to do here, though, folks, while we get started and get the questions prepped, I'm going to go through some audience participation here. We got some poll questions, which we're going to ask you to vote in while we are going through the questions. So the first poll question today: what is your top priority for this coming year? As we're going through the questions, vote in these polls and let us know what you think. So first question for either, I guess for you here, James, can you preview the policy product roadmap?
Yeah, so that I forget which slide that was on, but the most important things on our roadmap that are coming up very soon are the ability to configure your own policies. That's kind of a no-brainer that you need more fine-grained control over which policies you apply to which repositories and so on. So that's coming very soon. The next most important thing is probably the ability to group those policies in interesting ways. So you may want to assign, say, a production group of policies, so you can keep an eye on production, maybe in a blocking mode, but then use the policy iterative Delta stuff in development. So that's also coming soon. And then, of course, many more out-of-the-box policies. And that's where we would really like your input. We have people requesting policies around supply chain. So, for example, you should only accept base images that are signed by Docker, or we must have SBOMs attached as attestations to our images and so on. And so some of those things are coming, but this is where we would need your input.
Great. And that's a perfect segue into our next question for you, James. Which parts of the software supply chain that you just mentioned does Docker Scout help to manage and secure?
Well, that's a tough question. I think if you take Docker official images into scope and the rest of the Docker software, then I think it's fair to say all of it, in as much that building and signing Docker images and generating high quality SBOMs at build time, through consuming those into your own images, pulling Docker official images from Docker Hub, and then Scout to actually give you the observability that you need across your supply chain, all the way through your software development lifecycle. So I think Docker's software together does the whole thing, and Scout at the moment is very much focusing on policy and improving from a developer perspective. Hopefully that answers your question.
Yeah, absolutely. Got you on that one. Okay, let's put up another poll question then. The next one is, what is your timeline for evaluating new tools to add? So while we're going through some more questions, give us your feedback on your timeline for adding new tools to your environment. And while we're doing that, let's get into another question here, James. Someone wants to know, what does VEX mean? And how does it work? So obviously this is VEX in the context of Docker.
That's a good question, and I think it's an evolving landscape. So VEX stands for, I think, Vulnerability Exploitability Exchange or some such.
I think that's right. Yep.
Okay, thanks. That's just off the top of my head. And it's a way of software vendors and software consumers, software users, exchanging hopefully signed attestations about whether or not a vulnerability is actually relevant to a piece of software. So it helps remove those false positives that Alan was talking about. So a vendor can say, hey, although we've got Log4 Shell or whatever the big thing is in this piece of software, it's not exposed, so don't worry about it. And all of the scanners out there can calm down. So that's what it is. And in the context of Scout, there is some support evolving on the Scout backend, where we can ingest VEX and add attestations to images. However, it's quite a fragmented space at the moment, and there are many different tools, and it hasn't really settled out yet. But as the standards and APIs solidify, we're definitely jumping on board with all of that. And you can definitely add your own VEX in a feature coming very soon.
Right. Okay. Thanks. So got a two-parter here. Chris wants to know, how long does it take to deploy Docker Scout? And I would add on to that as kind of part B, how steep is the learning curve once you have got it installed?
Both good questions. So to the first one, I think that kind of depends. You get more out of Scout the more you put in. I think if you go to scout.docker.com now and log in with your Docker account, you can start getting some value from Scout straight away on the free account. And so to that extent, it's very, very fast. But the more you integrate with Scout and the more work you put in, the more you get from it. So, for example, if you integrate with CI using the GitHub action, that doesn't take too long. Especially if you have a shared workflow, you can plug it in across all of your GitHub actions, for example. But one of the most important things is runtime observability that I mentioned before. So integrating something like Sysdig or our own custom solution into your environments so that you actually know what's running there is probably the most important thing, and that can take some time depending on your organization.
Sure. Okay. All right, let's put up our last poll question for this. Are you interested in talking with sales and solution engineers about Docker and or Docker Scout? So vote in that and let us know about talking with sales and solution engineers about Docker and Docker Scout. So James, here we go with another question. You've already talked a little bit about the roadmap, but someone wants to know, can you share more about Docker's plans for image signing and verifying?
Absolutely. So I work in that area myself, so I could talk and have talked about this at great length. In fact, at DockerCon in LA a few weeks ago, I did a talk, so do look that up. And what we're doing is pretty exciting. So we're combining what's called the update framework, also known as TUF, with a technology called OpenPubKey to provide a signing solution that doesn't require as many moving parts as the other signing solutions out there, and is tied into OIDC providers like GitHub or Google or what have you. So that's the short version. There are blogs out there, so do a search for Docker and OpenPubKey on the internet. You'll find our blog. There are Git repos out there, and go to the community Slack as well, and ping me in the security channel, and I can give you a whole bunch more detail.
Sounds great. Sounds great. I think we got time for one more question here. Luis wants to know, what are the best tip, or I guess you can do several tips if you want, to make sure you have a clean and secure software supply chain. So this is maybe not specifically for Docker, but you can make it kind of Docker Scout specific as well if you'd like.
Well, there is one thing that I always say, which is a great question, and it's difficult to narrow it down to one, but I will try. But I think the single most important thing you can do in your supply chain is stay up to date. And that's whether or not you use Scout or Dependabot or manually updating your dependencies. The single most important thing you can do is stay up to date. Most of these vulnerabilities are in old software, and they're often getting patched quickly. And so to CISA's point about vulnerabilities in open source packages, they're fixed pretty quickly and they need to be updated. So that's the first thing you should do. And I won't go any further. That'll do.
I would add here that it's still remarkable to me, James, how many issues continue to be caused by software that has not been updated. You know, I mean, it's remarkable. So many breaches, so many compromises happen because of vulnerabilities for which fixes have existed for years in many cases, and they still just haven't been patched. You have to wonder,
right,
you know,
yeah.
what do we need to do?
Yes, that's right. And I mean, maybe it's the second thing, but to your point there, why they're not being updated, a lot of people don't even know they're running it. And so that's where the observability piece comes in. You really do need something running in your environments, reporting back exactly what is running so that you can have some idea of what needs updating. You know, do you have Log4j sitting in there or Heartbleed sitting in your production environment? And you need to know that before you can have any chance of updating it.
Yeah, exactly. You can't fix what you don't know you have. You know, pretty simple formulation. Okay, those were some great questions. I want to thank our attendees for all those great questions. Final thing for you before I let you go today. You've presented so much great information here on Docker and Docker Scout. For somebody who wants to take that next step, James, what should they do right after this event is done?
I would go to docs.docker.com and check out the Scout pages, or pop into our Slack and say hello, and I can put you in the right direction.
Outstanding. I also want to mention to everyone again that you've got all those handouts 6 of them, and they are in the handouts section. I would encourage you before this event is done in a few minutes to download those because they are absolutely free. Well, James and Alan, this has been so much fun to have you on. I learned a whole bunch, and I think all of us did who are listening today. Thank you for your time, and thank you for your presentations. They were really illuminating.
Thanks, Keith. Thanks, Alan. Thanks, everyone.
Thank you.
Thank you, Jen. Thank you. Thank you.
Thank you, Alan. All right, everyone. Great stuff. I always love hearing from Docker and what they're doing. Such an innovative company. And now, before I let you go, one last piece of business, and that is the Amazon gift card prize drawing, $250. And the winner is Seth Hunkins from Maine. Congratulations to you, Seth. We will be in touch ASAP to get you your card. And with that, everyone, we are out of here. I want to thank Docker for making this event possible. I want to thank all of you attendees for being here, for your interest in this topic, for spending part of your day with us. That concludes today's event. Now, get out there tonight and be scary.